This video is over topic 22, numbers 1 and 2, using the empirical rule with a curve. So the empirical rule states the percentages corresponding to how many standard deviations you go from the mean. So within one standard deviation is 60% of the data. Within two standard deviations is 95% of the data. And within three standard deviations is 99.7% of the data. You need to learn, memorize, have a diagram, something where you know that. The actual percentages will be multiple choice, but you need to memorize what they go with. So when you see the 95%, you need to know that's two standard deviations each direction from the mean. When you see 68%, that's one each direction, and so on. We pretty much have covered almost everything by going three standard deviations from the mean. There's a very small percentage beyond that. So really, you won't be asked about these percentages, the 0.15, 2.35, 13.5, and 34 on like homework quizzes, etc. So you really just need to know this part. But some of the practice questions here use all of them. So I'm going to, let's just do this. I'm going to take a screenshot of this diagram so that we have it handy. All right, zoom down on this a little bit. Okay, so number one, so one thing you can do is you can make a curve. So you won't do this in Alex, but you can do it on your own to help. So you take the normal curve. So just draw yourself a little bell shape. You're going to have these vertical lines, one in the middle. That's always going to be the mean. And then 1, 2, 3 to the right. So this first one is about halfway down the curve vertically, and then the same distance horizontally 2 more times. Same thing in the other direction. So the mean, you'll be told the mean and the standard deviation always. So the mean is 517. That goes here in the middle. That's represented here by this X with a bar over it is the mean. And then when we go X with a bar plus S, that means the mean plus standard deviation. This would be the mean plus the standard deviation plus the standard deviation again, or plus 2 times the standard deviation, and then 3 times. So from the mean, I'm going to work my way to the right. I'm going to add the standard deviation 12. So I'm adding 12. 517 plus 12 is 529. Then I do 529 plus 12 is 541. And then 541 plus 12 is 553. Then going the other way from the middle to the left, I'm subtracting. 517 minus 12 is 505. 505 minus 12 is 493. And 493 minus 12 is 481. So I'm going always from the middle, starting with the mean as my starting point. So this then gives me numbers that define or that correspond to the 68%, 95%, 99.7%. So I'm going to write these over here because I'm going to scroll down and I'm not going to have this anymore. So we had 481, 493, 505, 517, 529, 541, and 553. So what percent would you expect to contain between 505 and 529? I go and I find 505 and 529 here. Those are defining this middle group here. That's the 68%. Okay, then the next question, it is likely that 99.7% of bags contain between blank and blank. I find my 99.7, or you need to know the 99.7. So 99.7 means I'm going all the way out here to my 553, all the way out here to my 481. I give the left to right, so the 481 first, and then the 553. Okay, then that's what you'll have as far as like in ALEKS. A couple other things we could do with this. What percentage of bags would you expect to have more than 529 M&Ms? So for that, I would go and find the 529, and I want anything more than that. So that's going to be these three pieces. So I add up the percentages for those three pieces. And that adds up to 16. Then what percentage of bags have less than 493 M&Ms? I'm going to find my 493. I want less than that, so that's going to be these areas. So the 2.35 and the 0.15, add those. So that's 2.5%. And then if you buy 201 pound bags of M&Ms, how many would you expect to have either more than 553 or less than 481? So more than 553 would be this group here. Less than 481 would be this group here. So we're just looking at these two tiny little ends. They're 0.15% each. That adds up to 0.3%, and we take that percent of the 200, which is 0.6 bags. So that would be, I could maybe say, maybe one bag. That would either be extra big or extra small. Now, here's something you will be asked to do on homework, on quizzes, on tests. You'll have this diagram here, and you're filling in some of these labels. So you're not doing the full label with all 7 or all, what is that? Yeah, 7 numbers. You're just doing 3 of them. The one you're always doing is the middle one, is going to be the mean. No rounding, no calculation, just the mean exactly as given. So this means 68.6 pounds. That's B. Now, a couple things. W and U are equal distances from V, and those distances are going to be some number of standard deviations. So to get from V to W, I'm going to add 1.5 some number of times. To get from V to U, I'm subtracting 1.5 some number of times. Again, no rounding, nothing else. Now, these numbers here are to help you tell when you've gone far enough. You are not doing any calculations with those. So those, no calculations from those. So you're not adding 1.5 or subtracting 1.5 from any of those given labels. All they do is tell you. Now they are to scale. So we can tell W not only is between 70 and 72, but it is closer to 72. U is between 64 and 66. It's closer to 66. But if in doubt, what you can do is do all 3 times. So from the 68.6, I'm going to do plus or minus 1, plus or minus 2, plus or minus 3. This is representing how many standard deviations. So 1 standard deviation. So I'm starting with the 68.6. If I add 1.5 one time, I get 70.1. If I add 1.5 again, I get 71.6. And if I add 1.5 again, I get 73.1. So those are my possibilities for W. W has to be one of those three. It's W. For U, I'm subtracting. So 68.6 minus 1.5 is 67.1. Minus 1.5 again is 65.6. And minus 1.5 again is 64.1. So those are my possibilities for U. Has to be one of those. Now, the other thing is, again, they're equal distance. So whatever I choose for W, if I choose this, it would have to go with this, right? So they're going to match up. And then I use, you might recognize like the shape to say, oh, this looks like probably the 95%. You can use that as you get used to what they look like. Say like it's, about halfway down. Maybe it's a little farther. Maybe it's the, well, the 68. I think the first one is pretty much halfway down. So it's this, like somewhere in here would be this 68%. So you can kind of tell by just like how high it is, those or how far out it is relative to the curve. But you don't need to go by that. So I look at my numbers. 70.1 is between 70 and 72, but 71.6 is also, so it's probably the 71.6. And I can double check. So 67.1 would be here, somewhere in here. So if it can't be 67.1, it also can't be 70.1. 65.6 fits for U. And so those go. 64.1 would be over here. 73.1 would be over here. So it can't be this, therefore it can't be 64.1. So it has to be 71.6 for W and 65.6 for U. Now, since those were the two standard deviations added and subtracted, so plus or minus 2 standard deviation makes that be the 95%. So, you know what I mean? If it was one standard deviation on each side, so if it was the 70.1 and 67.1, that would be 68%. This one is the 95%. And if it went all the way out to 3 on each side, it would be the 99.7. So that's working with the empirical rule with labeling a curve.